Good morning, ladies and gentlemen. Thank you very much for joining this session where we will be reviewing the status of the standardization for 3GPP on the new RAD. Today we will be covering different topics. We will start with a quick introduction of the 5G use cases and the timeline, that is the general 5G timeline. And then we will cover three main topics. We'll go through the study items already open for new RAD in the 3GPP. We'll go through an update of the discussions and agreements on the new RAD technology that is happening in the different working groups. And we will cover a little bit of the new RAD acceleration discussion that is happening in the last couple of RAN plenary meetings. So these are the three main points that we will be covering today. One important topic is, we are trying to summarize here several hundreds of documents. So there's lots of information on the slides. I will not be going through all of the details of every single point in the presentation, but the presentation will be available to you so that you can have access to that information. I will be just picking some specific points and highlighting some details. If not, we could be using the whole day today just to go through this information. So, quick review of the 5G initial use cases. There are three main use cases being discussed for 5G. The most well-known is the enhanced mobile broadband, the EMBB, and that's essentially what we have today with LTE, but put on steroids. So we have with that more speed, more throughput, more bandwidth, and support for more users. We are talking about peak speeds in the range of 10 to 20 gigabits per second at some point. We are talking about an average perceived rate from the user's point of view of not less than 100 megabits per second. That in many cases is the maximum that you can get with LTE today in many deployments. And the expectation is to increase the total traffic in the range of 1 to 10,000 times the traffic that we are having today. So that puts a very big constraint in the operators, because if they scale the traffic with the current power consumption, that will impact very much the power needs for the network. So one important topic in the new RAD discussion is how to save energy in the network, and the estimation is in the range of about 100 times. So that when the traffic increase by 1,000 or 10,000, we don't need a power plant close to each of the network elements. So as I said, this is the most well-known use case, and probably the first that will be deployed not only in the 3GPP RAD, but probably even in the pre-5G networks that will be put in place in the next couple of years. The second use case is the massive machine type communication. That's a hot topic in the last 12 to 18 months, and there has been lots of standardization effort in 3GPP in order to support the massive machine type communication based on LTE technologies or some technologies that are close to LTE. And we have category 0, category M, we have the NB-IoT technology, but obviously this will be a use case for the 5G networks also. Here main topic is the high density of the devices. We are talking about several hundred thousands up to million of devices per square kilometer. That's really lots of devices. And it puts a big constraint on the network because of the access of many devices. Even if they are very low throughput devices, they all will be accessing to the network. So some research have to be done in terms of the asynchronous access. Important topics for the enhanced mobile broadband use case are the battery life, where there's a minimum requirement of 10 years, and in the latest technical report from the 3GPP, it says 15 years desired, the low cost, and the long range. Because at the end of the day, some of the use cases will deploy the devices in basements and areas where the coverage is not so good. So there's a need for a long-range support in this type of use case. And then the third use case is the ultra reliability and low latency. Probably is the less mature of all of them, and it's related to future services like connected cars, autonomous driving, remote surgery, and these type of things. And this is a use case that is very much interesting for most of the operators, because at the end of the day, they believe they can offer new services based on these use cases, and they can increase the revenue based on these new services. Because especially the European operators are thinking, okay, can we increase our revenues by deploying eMBB? Well, in Europe, for example, people is not willing to pay more to have a faster access. But people would be willing to pay more to have some quality of service embedded into their connections. And that's what ultra reliability and low latency use case is about. It's about providing a service with a specific level of QoS. Here we are talking about latencies in the range of less than 1 millisecond for the air interface and less than 5 milliseconds for the end-to-end. Very high reliability. We are talking about 4 nines reliability, and that's pretty high. And the demands for data rates probably is not as high as in enhanced mobile broadband. We are talking something in the range of few tens of megabits per second. That is what is required for these new use cases. So these are the 3 use cases, and this is what somehow puts the requirements and allows the beginning of the discussions about which technologies will be deployed for the new RAT for 5G. In terms of timing, until let's say beginning of this year, most of the industry has been doing initial research, and it was this year when the standards development started. We are expecting products to come to the market in late 2018, 2019, and we expect commercial deployment of solutions based on the 3GPP standard happening about 2020. That doesn't mean that there will be early developments based on proprietary standards, and there's a track happening in parallel to all of the 3GPP discussions with several network operators defining their own proprietary specs and working with vendors to have both network elements and terminal devices able to support that proprietary spec. And in that bucket, we have Verizon in the US or KT here in Korea. They both have plans to deploy networks well before the 3GPP standard is available. One organization to talk about when talking about 5G is the ITU, the International Telecommunications Union. They don't develop a technical standard, but somehow they define what are the characteristics of a 5G network that in ITU terms is IMT 2020, and they were working in pre-standard research for the last few years and created the technical requirements document early this year, late last year, as well as the evaluation methodology. As I said before, they don't create a technical standard. They receive proposals from several different standard development organizations, and they evaluate them against a set of criteria and decide if those proposals meet the requirements to comply with the IMT 2020 specification. That process will happen in 2018-2019, where different standard development organizations will be submitting proposals to ITU. And it will be in 2020 when ITU will make their decisions about which standards will comply with IMT 2020 and which ones will not comply. We know there's a standard development organization that will be submitting a proposal, and that's the 3GPP. And the 3GPP is in this line here. We are at this moment in the context or in the timeline of Release 14. Release 14, from the standardization point of view, is mostly focusing on LTE and also in evolutions of the NB-IoT technology for MMTC. But there are a number of study items that are being done in the context of this Release 14. We'll talk in the next part of the presentation about those 3 study items and what are they evaluating. And it will be in the context of Release 15 when standardization will take place. So at the end of Release 14, at the end of the study items, what we will have is technical reports. It's not a standard. It will be after Release 14, after Release 15, when we will have a technical spec that is a 3GPP standard. So in more detail, we have these 3 study items running. Channel model work study item is already completed, although there are still many discussions about the channel model defined there, and there are changes to the current TR. Then we have the scenarios and requirements study item that got its technical report just approved at the end of last week. It was email approval after the last 3GPP run plenary. But this study item will be kept open until March 2017, so that this preliminary technical report can be provided to ITU and then get feedback to ITU about these specs and these key performance indicators of the new rack technology that is being defined now. And then there's a third study item that is the 5G new RAD. That's the technical study item where the discussions about waveform, frame structure, protocols, testing, etc., are happening. And as part of this study item, there will be several technical reports, the series 38.8 something, 802, 801, 802, 803, 804, that will cover all of the studies done by the different working groups. Run 1 is the working group that deals with the physical layer aspects of the spec. Run 2 is the group that deals with the protocol layer aspects of the spec. Run 3 is the group that covers the radio access network architecture, and Run 4 is the group that covers the fundamental RF aspects as well as the test requirements for the new RAD technology, or for any of the 3GPP technologies. After that, after these 3 study items are finished, and this will happen or is planned to happen in March 2017, work items will be open to create the standard. And the first work item will be the 5G new RAT in phase 1, that will be in the context of release 15, and there will be a second work item in the future that is a phase 2 of the new RAT that is in the context of the release 16. What will be included in phase 1 versus phase 2? Well, it is still under discussion, and we'll have some slides later that talks about that. But I would say that at this moment, phase 1 will be mostly focused on enhanced mobile broadband up to 40 gigahertz frequencies and some of the ultra reliability and low latency use cases. The rest of the functionality, that is any type of waveforms or networks above 40 gigahertz, the full ultra reliability and low latency, or the massive machine type communication will be probably part of the phase 2. So that's a quick introduction, and now we are covering the 3 main points that I said before. The first one is talking a little bit more in detail about these 3 study items that are at this moment running in the 3GPP. So first one is a channel model, and what I would like to highlight here is this channel model. It's intended to cover from 6 gigahertz up to 100 gigahertz. So that's the whole frequency range that is being targeted by the new RAT technology. The results are available today because the study item as such is closed, and it's in the TR 38.900. All this information is publicly available in the 3GPP webpage. So you can get there and download that channel model specification if you are interested. Since the completion that happened in June, in the RAN meeting that we had in Busan, in Korea, there has been a number of change requests proposed to the channel model defined in this technical report. And these are covering many different aspects of the channel model with, well, for example, something to consider, especially is the spatial consistency. The current channel model is still a little bit weak in terms of spatial consistency, and you can get different channel models if you move like 9 millimeters from the position, and that's a big issue. So there are still ongoing discussions. Channel model, let's say there's a first version of it available, but there will still be lots of fine-tuning happening in the next few months to have a really solid channel model to emulate the 5G or the new RAT propagation. The second study item that we mentioned before is the scenarios and requirements, and it has 2 main objectives. The first objective is identify the typical deployment scenarios that will be targeted by the new RAT. And these scenarios are those one here, with some of them with higher priority, like the indoor hotspot or the dense urban, some others with lower priority and most likely part of the phase 2 standard when it comes, like, for example, the extreme long distance coverage or the light aircraft scenarios, on some others. But as you can see, the range of scenarios is pretty wide. So NR, the system defined in 3GPP for 5G, it's really covering many different types of deployment scenarios. The second objective is develop specific requirements for the NR, some key performance indicators that we will be seeing in the next slide. The results of the study items are documented in the TR 38913 that was just approved last Friday, and as I said before, the study item will be kept open in order to add whatever feedback we get from ITU, for the International Telecommunication Union. Some of the key performance indicators for the new RAT are well known, and the peak data rate will be 20 gigabits per second for the downlink and 10 gigabits per second for the uplink. The peak spectral efficiency will be in the range of 30 bits per second per hertz for the downlink and 15 for the uplink. That's very much aligned with what you can get from LTE. The control plane latency should be 10 milliseconds, but the user plane latency will range from different values depending if you are targeting the low latency use case or the enhanced mobile broadband use case. And we are talking about 0.5 milliseconds in the case of ultra reliability, or 4 milliseconds in the case of enhanced mobile broadband. One of the targets of the new RAT is handling the mobility, handling the change from base station to base station and from bin to bin with virtually no impact. So the target for the mobility interruption time is 0 milliseconds. So the user should not notice that it's changing from one base station to another, or that it is changing from one beam to another when moving around. In terms of reliability, we are talking about 10 to minus 5 numbers of figures for reliability. The coverage also is an important topic, especially for the massive machine type communication, and we are talking about 164 dBs. So that's an improvement over what we have in LTE, and that's very much aligned with what we have in NB-IoT today. The target for UE battery life, 10 years, but 15 years desirable, and mobility should be up to 500 kilometers per hour. That is much higher than what we have defined today in the LTE standard. This is a requirement driven by quite a few operators, especially to support the latest high-speed trains that are being deployed in different countries. The third study item is the technical study item. The study item where different techniques are being evaluated for implementation in the future new RAT standard. And all these techniques must support all the requirements and all the key performance indicators that we have seen in the last two slides. The detailed objectives of the study item are targeting a single technical framework that addresses all of the usage scenarios. So with one single RAT, we will be covering all of these scenarios that we have mentioned before. One important topic, and the reason of many discussions in 3GPP, is the forward compatibility. So whatever is defined today and for the release 15 spec should be forward compatible with the rest of the requirements that will be covered in release 16. That's somehow new in the 3GPP world. We have been handling backwards compatibility for some time, but we have never been doing a system thinking in forward compatibility. And that requires lots of flexibility in the definition of the new RAT. So that's the reason of, as I said, many of the discussions that are happening at the 3GPP level today. Then there's two objectives related to the study of the specific technical proposals, so evaluations, comparisons between the performance of different proposals, and then coexistence and the wireless relays. Wireless relays were, in theory, part of LTE, but they have never been well covered. In this case, the 3GPP and the different network operators and vendors want to make sure that the wireless relay concept gets embedded into the standard from the very beginning and is not a kind of add-on as happened with LTE. So this is a quick summary of the 3 study items open today. Now we'll go very quickly through some of the technical agreements and technical proposals that have been discussed in the working groups in the last 6 months. As I said before, what we are covering here in 3GPP, it's several hundreds of documents. So it's pretty high level, and even being pretty high level, it's about 10 or 12 slides. So we'll go very fast because we have about 15 minutes left, and I want to also cover the acceleration proposal that is, I believe, an interesting topic for all of you. So in terms of physical layer, there has been lots of agreements on forward compatibility, and essentially the system should allow paired operation, FDD operation in pair bands, but any of the pair bands can be used for either uplink or downlink. It's not like today where you have one channel for downlink, one channel for uplink. In the new RAD, you could be using any of those for both uplink and downlink. And there's also the agreement that for TDD operation, it will work in unpaired spectrum, both with dynamically changing transmission, so uplink, downlink changing dynamically, or not dynamically. So that's in terms of forward compatibility. In terms of waveform and multiple access, the main agreement to the moment is that for eMBEV up to 40 gigahertz, we will be using OFDM, CPU OFDM, so that's similar to LTE. But it doesn't mean that some pre-coding techniques or crest factor reduction techniques can be used. But in principle, the main target is CPU OFDM. So that's very similar to LTE. That's the same type of waveform that we have in LTE. In the future, some other additional waveforms will be added, and in fact, some other waveforms are being studied, and especially for massive machine type communications, probably there could be the different waveforms approved later in the process. It was agreed that in-band frequency multiplexing of different numerologies could be supported. So you can have different numerologies, that means different subcarrier separation, mixing together from the network perspective. And also there were discussions about supporting non-orthogonal multiple access in the uplink, at least for the massive machine type communication, as well as the autonomous, grant-free, and contention-based access for MMTC. As I said before, one of the main issues for massive machine type communication is how to handle so many devices accessing to the network, and in many cases simultaneously. So the traditional approach followed in LTE or other previous technologies, it's very limiting in terms of the capacity available in the RAD for accessing many devices simultaneously. In terms of numerology, there's a clear agreement that it will be based on power of 2 15 kilohertz frequency, and that should escalate between 3.75 kilohertz up to 480 kilohertz subcarrier spacing, although this value here is still under discussion. Once you select M for the numerology, it also fixes the subframe duration, and the subframe duration will be 1 divided by 2 to the power of m in milliseconds. So that means, for example, for a 3.75 kilohertz subcarrier spacing, you would get 4 milliseconds of subframe duration. For 15, you would get 1 millisecond, like in LTE today, or for 60, that is one of the possible targets for the first deployments, would be in the range of 0.25 milliseconds, so 250 microseconds. That's much tighter than what we have today. There were also a number of discussions about the length of the cyclic prefix and how to allow different cyclic prefix durations to be supported in the 3GPP. In terms of frame structure, some concepts were agreed, and were agreed the concept of subframe, a slot, and mini slot. A subframe will be 14 OFDM symbols, with a slot being something smaller than 14 OFDM symbols, and you can fit an integer number of slots into one subframe. This is the slot will be one of the scheduling units for the new RAD. The other scheduling unit, and that's a new concept, is the mini slot. And the mini slot is something smaller than the slot. That's the minimum scheduling unit for the new RAD. And this is intended mostly for ultra reliability and low latency. So with that, you can schedule very small amount of information and send pretty fast, so that you can cover the low latency requirements for that use case. The number of subcarriers per resource block are either 12 or 16. Both are being studied at this moment, and a decision will be made in the next meeting, that is in Lisbon next week. So very soon we'll know if the selection is 12 or 16. When different numerologies are multiplexed in the time domain, the subcarriers are located in a fixed grid relative to each other, and we can see here that if we have in the x-axis the frequency for different numerologies, we have the resource block aligned in this type of grid. Another interesting agreement is that for the HARQ feedback, multiple DL transmissions can be grouped together into a single uplink data or control region for acknowledge or no acknowledgement of the downlink signal. And that's good because it will reduce the signaling overhead of the system. And finally, a slot can be either all downlink or uplink, or something that is new today, can have a mixed uplink and downlink, with a downlink dominant slot, for example, that would have a small part in the uplink just to confirm the reception of the data, or an uplink dominant slot that would have a small part for downlink, where you can send control information for the subframe or for the slot. So that this part is somehow new and is aligned with the context, with the concept of the self-contained subframes that is being discussed in New RAD, and has big importance for the keeping the latency as low as possible. In terms of channel coding, most of the studies are focusing today on LDPC. A decision will be made also in RAN 186 bigs next week, but most of the effort at this moment is being put in the evaluation of LDPC. And there has been an initial discussion about outer coding. That's an interesting topic because somehow it allows very low latency slots to override some information that is targeted for an EMBB slot, and with that keep the latency very low. So it does a kind of puncturing of the information being sent on enhanced mobile broadband, and with that you get the latency critical slot, this red slot here, being sent exactly when it is needed. This is early discussions, but it's important to keep track of that because will be important for the low latency use case. In terms of multi-antenna schemes, a number of beam management procedures have been defined that allows to select transmitter beams in the TRP and receiver beams in the UE, and then P2 and P3 allows to refine the transmitter beam or to refine the receiver beam later in the procedure. Also, a number of concepts have been defined, like beam determination, beam measurement, beam reporting, and beam sweeping. In terms of random access, discussions and initial design of the random access procedure, it's been discussed, taking into account both the use of a single beam or multiple beams for this random access, and also taking into account the use of reciprocity or non-reciprocity between TX and RX that is important for the millimeter wave frequencies. Another topic being discussed is how to move from the initial wide coverage in the network side, where system information is being broadcasted in different beams, and what's the process to get to a single beam connected directly to a UE, and how to keep the specific beam forming in the data channel when the connection is set up with the phone. So in this topic there has been some progress also in the 3GPP. In terms of protocols, there's discussions on the user plane and on the control plane, and there has been agreements on the split bearer support for LTE NR dual connectivity. There has been lots of discussions and still ongoing about where to put concatenation in RLC, in MAC, if that will get duplicated or not. That's an ongoing discussion. There's no decision made yet, but there was an agreement in terms of HARQ that it will only be supported asynchronous HARQ. And there were also agreements about the how to aggregate, or the possibility of aggregating several carriers with different numerologies each. For the control plane protocols, there was an agreement to have one RRC state, at least, for low activity that should be, in terms of efficiency, comparable to what we have today in the LTE idle state. There were also agreements about the system information block, information that will be broadcasted periodically that support cell selection, the acquisition of other system information blocks, or the access of the cell. And now it's being studied the mechanisms to deliver the other system information blocks that can be either network triggered or UE initiated. So there will not be lots of information broadcasted in the network as it is done today in LTE. There will be just a minimum amount of information broadcasted in the network, and then the rest of the information required for a UE will be sent specifically to that UE when required. So with that, we will reduce the overhead of the network, and at the same time, we will reduce the power consumption in the network, because we will not be broadcasting lots of signals that are not really required every time. And then there were some more agreements around LTE to new RAT interworking. In terms of RAM 4, so testing and RF performance requirement, there was a good agreement in terms of ACLR, where it is assumed that it works in the spatial domain. So that means when you have a beam, the beam shape will be considered the same for both the wanted signal and the adjacent signals. So you will not need to do different types of procedures to get the adjacent signal and the main signal when measuring the ACLR. And there's a principle or agreement still to be confirmed for the same in ACS, so in the receiver side. Lots of discussion about user equipment RF requirements. It is widely accepted that about 24 gigahertz testing will be done over the air, and a number of parameters or requirements have been discussed for transmitter, receiver, and beamforming on the UE side. Same for base station, and there has been in that context most of the discussion about ACLR that could be based on TRP or EIRP, where you are measuring mostly at the center of the beam. Some other discussions about EVM and output power are happening. I would say that from the Ramford perspective, from the testing point of view, things are already in a very early stage. So there are no so clear agreements as what we have seen in terms of physical layer, for example. There has been also lots of discussion about testability, and some of the highlights on testability is, assumption that most of the tests will be done over the air. Also discussions about the possibility of testing at intermediate frequencies, and there will be quite a bit of measurements that could be done at intermediate frequency, as well as some initial agreement that the baseline for measuring base station RF could be based on a test setup similar to what we have today in LTE for the active antenna systems, for the adaptive antenna system, the AAS, defined in the 37145. So that's the second part. I went quite fast, but you'll have all this information available for you, so you can go through that. And if you are interested in discussing about some specific topic, I'll be available after the presentation in the break, so you can just come and we can talk about that topic. Last topic is the discussion about new RAT acceleration. That's also an interesting topic. It came up in the June RAM plenary in Busan. A number of network operators, as well as several infrastructure vendors, chipset vendors, and UE vendors, came with a proposal to have an early drop of the standard, mostly covering enhanced broadband, but earlier than the release 15 standard. So they wanted to get a first version of the NR, covering just a small subset of the requirements much earlier than the timeline for release 15. There was quite a bit of discussion in that meeting, and the agreement that happened at the end of the meeting was that there will be a checkpoint defined in RAN 75, that's in March 2017, and at that time all of the study items that we mentioned before will be completed. And one of the important points of that checkpoint is that the different working groups, RAN 124 and also SA2, will make a report on the forward compatibility both for the non-standalone and for the standalone. This is an important topic because if forward compatibility cannot be guaranteed in one way or another, the work done for release 15 and any possible acceleration that is done in that context will have a high impact in how things can be supported later, how the next use cases can be supported later. So this is an important point. In March, we'll have more information about that. And based on all that information, the new RAT timeline will be reconfirmed or not, and there could be defined an early drop of the specification for the non-standalone earlier than the June time frame. That is the target for the release 15. June time frame 2018. So what happened after that? Well, 3 weeks ago, there was also a RAM plenary, this time in the United States, and some of the companies that were not really happy with this agreement, thought that the agreement was a little bit light, came with another proposal to accelerate again the 3GPP NR spec. And again, there was lots of discussion, and essentially was reconfirmed this checkpoint, and there was a statement coming from that RAM plenary where it was said that there is a strong interest on having a non-standalone version of the standard based on network option 3 or 3A. That are those two options here, somewhere between or sometime between 2017 and March 2018. And it was also covered there that there's also a strong industry interest in completing the standalone based on option 2, that is this one here, that's with the next gen core, with a new core network, and also based on some other of the network options. So that was the final outcome after the meeting. Together with that, there was an agreement by the different RAN working group chairs about how to use the time of the next working group meetings. And there was an important agreement that there's a list of items that we'll see in next slide that will not be covered at all in the next RAN 1, RAN 2, RAN 3, RAN 4 meetings in order to accelerate the rest of the standard. They can only be covered in the context of forward compatibility. So all this list here doesn't mean that they will not talk a lot about that, but they will talk about that only to ensure forward compatibility. So in practice, most of the work group time will be focused on sub 40 gigahertz, will be focused on enhanced mobile broadband, will be focused on ultra reliability and low latency. And for example, massive machine type communication will be left out of most of the discussions for the release 15 standard, or at least for the early drops of the release 15 standard, as well as these other topics. So in general, the view of the 3GPP is that massive machine type communication is well covered with the NB-IoT standard today, and V2V, V2X, side link, all these capabilities are also being now defined for LTE, so it doesn't make sense to work on that for 5G when the LTE spec is not completely close on that. And that's the last slide of my presentation. As I said before, in the break, if you are interested in getting some discussion or you have some questions, I'll be happy to talk with any of you. 감사합니다.